Namaste Elrigu. Welcome to Learning Management Systems, Department of Collegiate and Technical Education. Today I'm going to discuss about transistors and MOSFETs, Unit 2 of Analog Electronics. In this session, the following topics are covered: Introduction to transistors, types of transistor and their symbols, different regions and terminals of transistor and their functionalities. Before getting on to the introduction of transistor, let's have a quick recap on semiconductor devices that you have already studied in your earlier unit. So semiconducting materials are those whose conductivity lies in between that of conductors and resistors. They act like an insulator in its purest form, but when certain impurity is added, its current conducting capacity or characteristics can be changed. So based on the type of the impurity added, we have two types of semiconducting materials, that is p-type and n-type. When a trivalent impurity is added to a pure semiconducting material, the resulting material is a p-type material. And what do you mean by a trivalent impurity? Trivalent impurity are those who is having 3 valence electrons. Similarly, when a pentavalent material having 5 valence electrons is added to a pure semiconducting material, the resulting material is a n-type material. So p-type materials, they have holes as majority charge carriers, whereas n-type material have electrons as their majority charge carriers. These p-type and n-type materials alone are of not much use, but when these two types of materials are joined together with a suitable technique, then they can be used in many applications. So a simple p-n junction formed will give rise to a semiconductor device called p-n junction diode. So basically a semiconductor device is one which is having one or more than one junctions. ನಿಮ್ಮ p-n junction diode ಅಲ್ಲಿ ಒಂದು p-n junction ಇರುತ್ತೆ. So p-n junction diode, it conducts only when it is forward biased, whereas when it is reverse biased, it does not conduct any current. So this important feature of p-n junction diode is made used in your rectifiers. So what do you mean by a rectifier? Rectifier is a device which converts alternating current to direct current. So the next version of p-n junction diode is the transistor. So ನಿಮ್ಮ transistor, it has 2 junctions and 3 terminals. It has 3 layers. So each layer having one terminal, and hence it is a 3-layer, 3-terminal, 2-junction device. Transistors na ನಾವು bipolar junction transistor ಅಂತನೂ ಕರಿತೀವಿ. And transistors are most popular semiconductor devices among other semiconducting devices because of its lower cost, smaller size, minimum weight. Hence, it can be used in the development of miniaturized electronic devices. They operate with lesser voltages, they have longer life, they consume lower power, and they have very fast switching operation. The word transistor is derived from 2 words, that is transfer and resistor. Transistors are the main building blocks of digital revolution. The most technological wonders you are seeing today, for example, your cell phones, that wouldn't have been possible without these transistors. Transistors are quite complex, but it can be used in many ways. The most important feature being its ability to amplify a weak signal. Amplifier andre weak signal na strengthen mado device na ನಾವು amplifier anta ಕರಿತೀವಿ. Also, transistor can act as a switch and also as an oscillator as well. Now, let us briefly discuss about the transistor. As I told you, transistor is also called a bipolar junction transistor. Why it is called bipolar? Bipolar means Inside in the transistor, the current conduction is due to both holes and electrons. Andre holes ಮತ್ತೆ electrons ಎರಡೂ ಕೂಡ current conduction ನಲ್ಲಿ ಒಂದು ಪಾತ್ರನ ನಿಭಾಯಿಸುತ್ತೆ. As we all know, n regions, they have free electrons as majority charge carriers, whereas p regions have holes as majority charge carriers. As I said, transistor is a three-terminal two-junction device. The three terminals are emitter, base and collector, and two junctions are EB and CB junction. That is emitter base junction and collector base junction. Here you can see how two types of transistors, NPN and PNP transistors, are formed. In case of an NPN transistor, P-type material is sandwiched in between two N-type materials. In case of an PNP transistor, N-type material is sandwiched between two P-type materials. So for all the three layers, for the external connection, three terminals are taken out, and the terminals are the collector, emitter and the base. So based on the way the PN materials are arranged, we have two types of transistor, that is NPN transistors and PNP transistor. Now you can see in this picture, size wise your collector, ನಮ್ಮ collector size wise ಅಲ್ಲಿ ದೊಡ್ಡದಾಗಿದೆ, whereas the base in both the type of transistor is made very thin, whereas emitter is moderately sized. But doping level wise, emitter is heavily doped, collector is moderately doped, whereas base, which is the middle terminal, is very lightly doped. Andre emitter the function enu? Emitter has to emit majority charge carriers, hence it is heavily doped. Base ಏನು ಮಾಡುತ್ತೆ? ಈ ಎಲ್ಲಾ majority charge carriers ಅನ್ನ collector ಗೆ pass on ಮಾಡುತ್ತೆ, ಹಾಗಾಗಿ it is very lightly doped. And the collector, it has to collect the majority charge carriers emitted by the emitter, hence it is moderately doped. So let me summarize. A transistor, it has three doped regions. For both the types of transistor, that is NPN and PNP, base is made very narrow, and the base region, it is sandwiched between the larger collector and the emitter regions. The emitter region is heavily doped, and its job is to emit majority charge carriers into the base. If it is a PNP transistor, majority charge carriers emitted are holes. If it is an NPN transistor, majority charge carriers emitted are electrons. The base region is very thin and it is lightly doped. Most of the current carriers injected into the base passed on to the collector. The collector region, which is moderately doped, is the largest of all three regions, collects these majority charge carriers. Here is the transistor symbols. This is the symbol of an NPN transistor, whereas this is the symbol of a PNP transistor. In the symbol, we have two slant lines and one horizontal bar. The two slant lines indicate the terminals emitter and the collector, whereas the horizontal bar indicates the base terminal. As you can notice, there is an arrow mark in the emitter terminal. This arrow mark indicates the direction of the conventional current. It shows the direction of conventional current. In case of an NPN transistor, the current flow is away from the bar, that is away. This current is flowing away from the transistor. But in case of a PNP transistor, the current direction is towards the bar. That is, current is flowing towards the transistor or towards the junction. So here, let's have a brief discussion on the two junctions formed by connecting P and N material. Okay, in both the cases, in PNP as well as NPN transistors, there are two junctions formed, that is emitter base junction and collector base junction. For the normal working conditions of a transistor, the emitter base junction must be forward biased, whereas the collector base junction must be reverse biased. Since your emitter base junction is always forward biased, its resistance is almost zero in an ideal case, or it is very less. At the same time, since the collector base junction is reversed biased, its resistance is very high, or in an ideal case, it is infinite. It is infinite. So, the transistor operation can be thought as signal transferred from low resistance circuit to a high resistance circuit. So, transistor, it transfers signal from a circuit of lower resistance to a circuit of higher resistance. That's what I said in the very beginning of the session. Transistor, it is derived from two words, transfer and resistor. So here is the explanation for that. Since your transistor, it is transferring signal from a circuit of lower resistance to a circuit of higher resistance, it is called transistor, that is transfer resistor. So let's have a summarization. It has two junctions, emitter base junction and collector base junction. For normal operation of transistor, be it is PNP or NPN, EB junction is always forward biased and collector base junction is always reverse biased. EB junction forward bias ಆಗಿರೋದ್ರಿಂದ ಅದರದು resistance is very low or zero in an ideal case. Collector base junction reverse bias ಆಗಿರೋದ್ರಿಂದ ಅದರದು resistance high ಆಗಿರುತ್ತೆ ಅಥವಾ infinite in an ideal case. So at the end of the session, you have understood the concept, the basic concept of transistor. What are the types of transistor? We know the different types of transistor. We have PNP transistor and NPN transistor. P ಮತ್ತೆ N type material ಹೇಗೆ arrange ಆಗಿದೆ ಅದರ ಮೇಲೆ we have two types, PNP and NPN. ಹೇಗೆ ನಾವು PNP transistor ಮತ್ತೆ NPN transistor ನ symbolize ಮಾಡ್ತಾ ಇದೀವಿ. So the symbols of transistor, and we have also identified the three terminals of transistor. Transistor ನಲ್ಲಿ three layers ಇದೆ, emitter, base, collector. ಆ three layers ಗುನು external connectivity ಗೋಸ್ಕರ three terminals ಅನ್ನ ಹಾಕಿದೀವಿ, and these three terminals are called emitter, base, collector. And we have also learnt about the functions of these terminals. Emitter ಏನ್ ಮಾಡುತ್ತೆ? Emitter majority charge carriers ಅನ್ನ emit ಮಾಡುತ್ತೆ. So majority charge carriers ಅಂದ್ರೆ ಯಾವುದು? PNP transistor ಇದ್ರೆ holes, NPN transistor ಇದ್ರೆ electrons. So the majority charge carriers are injected by the emitter into the base. Base ಏನ್ ಕೆಲಸ ಮಾಡುತ್ತೆ? ಈ ಎಲ್ಲಾ majority charge carriers ಅನ್ನ collector ಕಡೆಗೆ ಪಾಸ್ ಆನ್ ಮಾಡುತ್ತೆ. ಕಲೆಕ್ಟರ್ ಏನ್ ಮಾಡ್ತಾ ಇದೆ? ಈ ಎಲ್ಲಾ ಮೆಜಾರಿಟಿ ಚಾರ್ಜ್ ಕ್ಯಾರಿಯರ್ಸ್ ಅನ್ನ ತನ್ನ ಕಡೆ ಎಳ್ಕೋತಾ ಇದೆ, ಕಲೆಕ್ಟ್ ಮಾಡಿ ಇಟ್ಕೋತಾ ಇದೆ. ಸೊ ಇವಾಗ ಈ ಸೆಷನ್ ಎಷ್ಟು ಮಟ್ಟಿಗೆ ನಿಮ್ಗೆಲ್ಲ ಅರ್ಥ ಆಗಿದೆ ಅಂತ ತಿಳ್ಕೊಳ್ಳೋದಕ್ಕೋಸ್ಕರ ಕೆಲವು ಮಲ್ಟಿಪಲ್ ಚಾಯ್ಸ್ ಕ್ವೆಶ್ಚನ್ಸ್ ಅನ್ನ ನಾನು ಫ್ರೇಮ್ ಮಾಡಿದ್ದೀನಿ. ಲೆಟ್ಸ್ ಗೋ ಒನ್ ಬೈ ಒನ್. ಸೊ ದ ವೆರಿ ಫಸ್ಟ್ ಕ್ವೆಶ್ಚನ್ ಇಸ್, ದ ಟರ್ಮ್ BJT ಇಸ್ ಅ ಶಾರ್ಟ್ ಫಾರ್ಮ್ ಫಾರ್. ಸೊ ನಿಮ್ಗೆಲ್ಲ ಈಗಾಗಲೇ ಉತ್ತರ ಸಿಕ್ ಹೋಗಿರುತ್ತೆ ಅಂತ ಅನ್ಕೊಂಡಿದ್ದೀನಿ. BJT ಅಂದ್ರೆ ಏನು? So let's look into the options. Base junction transistor, binary junction transistor, both junction transistor, bipolar junction transistor. So ಯಾವುದು correct answer? The term BJT stands for, yes, bipolar junction transistor. The next question is, what are the two types of BJT? We all know, right? ನಮಗೆಲ್ಲ ಗೊತ್ತೇ ಇದೆ ಎರಡು ಟೈಪ್ ಆಫ್ ಟ್ರಾನ್ಸಿಸ್ಟರ್ಸ್ ಯಾವ್ಯಾವ್ದಿದೆ. Yes, correct. NPN and PNP. So the options for this question are NPN and PNP, PNN and NNP, PPN and NNP, PTS and STP. So the right answer is NPN and PNP. Current flow through a BJT is by means of ಅಂದ್ರೆ BJT ನಲ್ಲಿ ಒಂದು ಟ್ರಾನ್ಸಿಸ್ಟರ್ ನಲ್ಲಿ ಕರೆಂಟ್ ಫ್ಲೋ ಯಾವುದರಿಂದ ಉಂಟಾಗ್ತಾ ಇದೆ ಯಾವುದರಿಂದ So the current flow through a BJT is by means of both holes and electrons. So let's look into the options available. We have the very first option as electrons, the second one holes, third one both electrons and holes, fourth one none of the above. The right answer is both electrons and holes. Conduction takes place with the help of electrons and holes as well, and hence bipolar. The next question is, in a transistor symbol, if slant line arrowhead is drawn towards the bar, then the transistor is what type of a transistor it is? Let's look into the options. First one is PNP, second one is NPN, third one is either of the above, and the fourth is none of the above. So which is the right answer? It is PNP. In case of a PNP transistor, the current flow is towards the bar, that is towards the transistor junction, whereas in case of an NPN transistor, current direction is away from the bar. So this is your fifth question. Which region of a transistor is lightly doped? We all know this. Base is the region which is lightly doped, right? So the options are collector, base, emitter, and all regions are equally doped. Okay, base is the right answer because it is very lightly doped. Collector, it is moderately doped, and emitter, it is heavily doped. Next question, which region of a transistor has highest conductivity? So ಯಾವ region ನಲ್ಲಿ conductivity ಜಾಸ್ತಿ ಇರುತ್ತೆ? ನಮ್ಮ ಎಮಿಟರ್ ನಲ್ಲಿ conductivity ಜಾಸ್ತಿ ಇದೆ. ಯಾಕೆ? Because it is heavily doped. So the options are base, collector, emitter, all of the above. The right answer is emitter because it is heavily doped. Hence it has highest conductivity among the three regions of transistor. So that's all we have for today. Thank you so much.